Hello friends, welcome to another power electronics concept session. Today we shall talk about the meaning and significance of di by dt rating of the SCR. This session aims at helping you understand the meaning of di by dt rating of the SCR and its importance in the context of SCR operation. di by dt physically means how fast the anode current is increasing with respect to time. It is the maximum allowable rate of rise of anode to cathode current. If di by dt of the SCR is exceeded in the circuit in which it is connected, it will lead to creation of localized areas of high temperature referred to as hotspots in the vicinity of the gate cathode junction. The temperature of hotspots may exceed the maximum allowable junction temperature of the SCR as specified by the data sheets. This will result in damage to the device. The figure shows a graphical representation of di by dt for two different cases. The line with higher slope represents a high di by dt where there is a very fast rise in anode to cathode current with respect to time. The line with lower slope represents a low di by dt where the anode current rises comparatively slowly with respect to time. Another important point to note is that if di by dt is high, current reaches a specified level I1 earlier, and if di by dt is low, current reaches the same level later. The figure shows a representational view of the SCR cross section. When the SCR is triggered on, the anode current rises from 0 to its maximum value at a rate determined by the elements connected in the circuit. This is the circuit di by dt. As the anode current is rising, it initially flows in a small area in the vicinity of the gate cathode junction. At the same time, the current also begins to spread throughout the junction across the cross section of the device. The speed at which current spreads across the cross section is referred to as current spreading velocity. Assume that the circuit di by dt, that is the rate of rise of anode current, is very high as compared to the spreading velocity of the turn on process. Then there will not be sufficient time for the anode current through the device to spread uniformly across the cross section of the device. This will result in localized areas of high current density in the junction regions, leading to creation of high temperature spots which may cause the device to fail. On the other hand, if the rate of rise of anode current is reduced, there will be comparatively more time for the anode current to spread uniformly over a larger cross sectional area. This will lead to reduced current densities and hence lesser chance of localized hotspot creation. The device will therefore not be damaged. Let us consider an example to elaborate the di by dt concept. Observe the figure carefully. We shall assume that the SCR is connected in a circuit having high di by dt of 800 amperes per microsecond. Due to high di by dt, anode current reaches 800 ampere in lesser time, specifically 1 microsecond in our case. Hence, for a given spreading velocity, the extent of current spread across a cross section of the device will be lesser. That is, 800 amperes of current will flow through a smaller cross section. Hence, current density will be high, leading to greater chance of hotspot creation and damage to the device. Now consider another case. Assume low circuit di by dt of 200 amperes per microsecond. Due to low di by dt, anode current takes more time, specifically 4 microseconds, to reach 800 amperes. Hence, current spread across a cross section of the device will be larger for the same spreading velocity. Hence, current density will be low. Now there will be lesser chance of hotspot creation and hence likelihood of damage to the device will be lesser. The data sheets of the SCR specify the maximum di by dt allowed for the device. A designer must ensure that the specified di by dt of the SCR must not be exceeded in the circuit in which it operates. Otherwise, the device will be damaged. We must ensure that circuit di by dt must always be less than SCR di by dt. That's it for now, friends. Thank you.